Hey guys, today we're going to be learning about enzymes and how they work. So enzymes are these things that speed up reaction. So the reaction could happen, but this speeds it up. An example might be, let's say I drove a car to California. That's going to take me a few days, right? But let's say an airplane is my enzyme, and when I get in it, I get there in a couple hours, right? So it sped up that reaction. So that's kind of what it does. They help speed up reaction. Okay, so enzymes are proteins. Okay, so remember they're proteins that speed up a reaction. Enzymes are proteins. This is important, right? So they're made through transcription and translation, right? Not all of those are enzymes, but that's some of them are. So what are the two actions of enzymes? Well, they either bind two molecules together or they're going to break them down. So it's either putting two together or pulling two apart. So it's going to do one of the two of these. So what is a substrate? So we know an enzyme is a protein that speeds up a reaction. A substrate is a molecule that binds to that enzyme. So if this is my enzyme here, this would be my substrate, right? So let me see, wait, let me go back. Okay, so this is what is going to cause the substrate is either going to be broken apart or maybe two substrates go in and it's going to be bound together. Alrighty. So what is an active site? Well, an active site is an area, it's the area where the substrate is going to bind to. So if we look here, it's like, see how this little notch is cut out here for the enzyme? The substrate is going to fit right in there. And fitting in this opening is called the active site. So let's say I have a key to my car, right? It will only work on my car. I can't go out to the parking lot and pick any car, right? It'll only work in my car. So, because it will fit into that area, the active site for my car. So that's how enzymes work. They're very specific, and you have to fit exactly in there in order to have this reaction. So that's what I'm talking about. They're very specific, and they only do specific tasks. Yeah, the example, my car key, opening up my car. I can't go and open other cars because it won't work, right? So it's very specific to my car, and that's how enzymes are and substrates. So here's a picture here where we're going to build two together. So we have two different molecules coming in. The enzyme acts on them, and they bond. They become a product, right? Something totally different. So there you go. So there are 4 steps of enzyme action. So first off, the substrate and the enzyme have to be in the same area. Okay, well, obviously they can't come together if they're not in the same area. So this one's kind of a given, right? It has to be in the area. Then that substrate has to bind to that enzyme. All right. So then once it does that, the reaction or the catalyst means reaction, happens. So, and then the product and enzyme separate. So they go their separate ways. So if I compare this to starting my car, I could have my key. Well, obviously I have to be in the area of my car to go into it, right? Because if I'm in a different city, it's not going to be happening. So then when I put my key into my car, um, and unlock it, that's like the reaction, the catalyst, because that substrate binding to that, well, the key in the lock and turning is the reaction. And so the product of this is, I have an open door. Very exciting. And enzymes can be reused because once they, like, just like my lock and key, right? Once I'm finished with the key, it comes back and I can use it again. So enzymes are the same way. So if we look here, um, step one, enzyme and substrate in same area, right? So they're hanging out in the same area. And then step two here, substrate and enzyme bind. So notice how the active site is a very specific shape and how the substrate has that shape and can bind to it. So then the reaction's going to happen, right? It's like me turning the key to my car. Something's going to happen. And then step four is the product. So in this case, it was breaking two things up. And these are my products of that reaction. And my enzyme, see, it's the same as in the beginning, and it's ready to be used again. So what is activation energy? This is the amount of energy it takes for a reaction to happen. So let's say, and the enzymes lower that activation energy. And I know that that seems odd, lowers the activation energy. So let's say I'm on a hill, right? And I'm on one side of the hill and my car runs out of gas, right? For me to push it up the rest of the hill, it's going to take a lot of energy, right? Huge amount. I'm going to be like, ugh. I'll probably get run over, okay? But if I get my friend to come behind me and kind of push my car up the hill, because there's a gas station down on the other side, that lowers how much energy I need to put forth, right? So now it's like, I'm sitting there pretty. I'm not like sweating and dying and everything else. So it lowered the amount of energy I had to use to get over that hill. So that's kind of what enzymes do. They lower that energy, the amount of energy it takes to make that reaction happen. So there are a couple things that affect it, right? And that's temperature. It could be too cold, too hot, and enzymes won't work. And this is a very important in case of, like, if you have a really, really high fever. They always say go to the hospital if it's 104. This is because um, at a certain point, your enzymes are not going to work anymore because they're going to be denatured, which is down at the bottom. But it has a huge effect. So that's why they're so neurotic about your temperature. And this is because of your enzymes. And also pH, which is the acidity. And so you can see this is, a large scale. This is like more acidic. So like oranges or lemons or limes, more of that. And this is more soapy. It feels like soapy. And then we have denatured enzymes. And that's when something is like blocking it or has what's called an inhibitor, so that the substrate can't actually bind to it because there's something in the active site that is messing with the shape of the active site. Hold on. Let's go. Maybe this is my last one. Okay, well, that was short and cute. Um, so make sure you finish your notes. Okay, bye.